morning all. Am I audible?
Yes, sir.
So we have seen the Coulomb's law. Now earlier you have seen that any mass, so for example mass m, okay, what it will be creating something called as gravitational field in the space around it. Okay, so you can see that now into this space, suppose you bring some mass. You bring some mass over here. What will happen? This will experience a gravitational force, no?
Yes, sir.
Do you agree with this or not? Similarly, the charge Q okay. Now suppose we're bringing another charge here. So if you place understood this or not? Clear?
Clear, sir.
Shall I turn this?
So 1 minute, sir, please, sir. 1 minute. Yes, sir. Completed, sir.
1 minute,
Right.
sir.
It is similar to the what we have studied in gravitation, no?
Yes, sir. Yes, sir.
So I can say that any charge this creates what?
Like a field around.
Other charges. Correct. That means we can say what are this?
Yes.
That means Earth is there. Gravitational field of the Earth, due to its own field, it won't be experiencing any force.
On other objects, it will.
Uh,
So you can say that the effects. Now, how do you measure this? Remember this? These effects can be expressed. Tell what you know about this. Their electric field intensity. Earlier it studied gravitation, no?
Yes, sir. Yes, sir. Yes, sir. Remember, sir.
The next one is electric potential. Remember all this?
Yes, sir.
Understood this?
Yes,
Is
sir.
it clear?
Yes. Clear, sir.
Now recollect, how did you measure the gravitational field intensity? Shall I turn this?
1 minute, sir. 1 minute.
Recollect how you have learned to find the gravitational
Gravitational
field.
pull by mass.
Hmm. Wherever you need the intensity, you used to place one mass, find the force on that mass. After that, you used to find force per unit mass. Shall I turn this?
1 minute, sir. Sir, the first line means that the particle can't experience any other force other than this electrical force.
Who told you that?
I
Did
mean,
I say
I'm
that you
asking,
don't? No, no. Did I state that other forces will not be there? What I said is any charge placed in a field will experience a force due to that field. It may have other forces, magnetic forces may be there, gravitational forces may be there. So the exertion of electrical force will not prevent other forces from acting, no. Each
yes,
will be
sir.
independent. Now let us see how to measure the electric field strength. To measure the strength of electric field strength. We want this. Now see here is a charge Q, say placed at a point A. Now this creates a field. I want to know at this point X. Okay, so I can say that if the source placed at point A, this produces
Field around.
so we have to find this electric field at some point. Here this is understood this. So here what we'll do, we'll wherever we need at whichever point we need to find the electric field strength. We place a small charge Q naught at that point. Okay, we find force on Q naught.
due to Q.
Say for example, this is Q naught. Okay, so here the force due to this will be force on Q naught due to Q. Agreed?
Yes, sir.
Is it clear? So now you can see that. Shall I turn this?
1 minute, sir. 1 minute.
1 minute.
Done, sir.
Right. See, suppose this is Q, a charge like this. Now to measure here at point X is a charge Q. Now when we place this to measure this at this point Q, what we should do? We should place Q naught. Now what will happen? Due to induction, most of the charge will go like this, no? Due to repulsion. That means the center will shift or not. That means Q naught should not produce any inductive effect. Agreed? Followed. Otherwise, what will happen? You are trying to measure the field due to this charge, whereas you are getting some other force, no? Because this distance is changing or not? Do you agree with this? Now you can see this R, the center of the charge, is moving away from here. Definitely, the force will be differing, no? Am I right or not?
Yes,
Hello?
sir.
So now you can see, so force experienced due by Q naught. Do you agree with this?
Yes, sir. Yes, sir.
So what we should choose? Q naught should not disturb the original charge distribution.
Could be neutral, sir. Then Q not.
Even its neutral also disturbed, no? Because induction can take place even between neutral body and charged body, no?
Yes, sir.
Shall I turn this?
Yes, sir.
1 minute, sir. 1 minute.
1 minute, sir.
And
Right. That means, note that even Q naught is also a charge, no? But it should be very small. Even Q naught creates its own electric field. Now this field should be negligible. Which is to be measured must not be disturbed. Agreed?
Yes, sir.
Understood this? So understood this?
Yes, sir.
Okay, understood.
So such a charge, that means for that, therefore Q naught must be as small as possible. That is, Q naught must tend to 0. Understood this? So such a charge is called test charge. So remember that test charge should not disturb. Agreed. So for example, thermometer is there. You are using thermometer to measure the temperature of substance. Now the thing is, the thermometer should not absorb more heat, no? Suppose a body has 100 calories of heat. So 100 calories of heat corresponds to some temperature. Now if you keep a thermometer, this thermometer itself absorbs some 20 calories of heat. Then it measures the temperature of what? 80 calories of the body, not 100 calories, no? So that is the reason why the thermometer should not absorb much heat. Understood this or not?
Yes, sir. Understood.
Yes, sir.
Yes, sir.
Clear? See, if I ask a person to deposit 1 lakh rupees in the bank, if he asks 100 rupees for auto charges, it's okay. Suppose I want to deposit 100 rupees and if that fellow asks 1 lakh rupees for auto, that is foolish thing. So here we are trying to measure the electric field of the original charge distribution. For that we are using another charge. The new charge should not disturb the original charge distribution. Such a charge is what is called as test charge. Follow till here.
Yes, sir, understood.
Yes.
So I can say that So we can say that wherever you need, this is Q. This I am placing a test charge here at a point X. Then you can see it experiences a force on Q naught due to Q. So that is some F. Then you can see Q naught test charge. Q naught placed experiences say force F. Now unit charge placed at point X experiences how much?
Sir, force by Q naught.
Okay, so this is as a measure of so I can say that understood this.
Yes, sir.
Shall I turn this? Shall I turn this?
Yes, sir.
Yes, sir.
See, suppose this is the uniform charge distribution. Say this is point X, this is center, this is R. Say if you measure the electric field here, okay, suppose we are having Q naught and Q naught is very small, then you have the force F. So measured value will be how much?
Sir, some force. F bar by Q naught.
Hmm. At point X is how much? F bar by Q naught. This is actual value. Okay, we will see later. Actual value will take. This is what we know, no? We define like this. Now suppose if Q naught is not small, then what happens is point X. Q naught is not small. That means it produces. Then you can see that this distance, these charges will go away, no? The center of the charge will move away, no?
Yes, sir.
Yes.
Then you can see if you keep Q naught here, it will be F1. Then you can have F1 by Q naught. Agreed. Now you can see as R1 is more than R, F1 bar is less than F bar. Therefore, F1 bar by Q naught will be less than F by Q naught. Agreed? Any doubt is there? Now you can see this is the measured value will be less than is less than. Understood this?
Yes, sir.
Is it clear?
Yes, sir.
Shall I turn this?
minute, sir. 1 minute. Done, sir. Completed.
Suppose a positively charged ball hangs from a silk thread. We place a positive then the four options he has given. Understood this? Tell which is correct. Hmm. Quick. Just now you have seen that
Done, sir.
then electric field will be that means E is more than agreed on it. Because measure value is lesser now. Hello?
Yes, sir.
Do you agree or not?
Yes, sir.
Understood this?
Yes, sir.
Any doubt is there till here?
No, sir.
No doubt.
So I can say that, shall I done this?
Yes. Yes, sir.
So we can conclusion is that test charge is very understood this? Clear?
Yes, sir. Clear, sir.
Shall I turn this?
Yes, sir.
So test charge is a very small positive charge. Now you can see F bar by Q is nothing but E now. That means what is force mean?
E into Q. Yes, sir.
If Q is positive, then force, do you agree?
Yes, sir.
If Q is negative, then
Opposite direction of E.
Do you agree?
Sir.
I can say that
Yes, sir.
this experiences force. Negative charge experiences in direction opposite to what? Followed. Now suppose this electric field direction, for example, now if I keep a positive charge here, so this will be the electric field E bar. So this will be experiencing a force in this direction. On the other hand, if I keep a negative charge here, it will experience a force in which direction? Positive charge will experience like this. This is negative charge.
Yes, sir.
Do you agree with this?
Yes, sir.
Yes, sir.
Clear on it? That means plus Q will have minus
Yeah.
Q but opposite direction. Understood this?
Yes, sir.
Finished this.
Minutes, sir.
Yes, sir. Completed, sir.
See, just now I posted one question. Finish that. Shall I go ahead?
Sir, 1 minute, sir. Please, sir. 1 minute.
See, there is a bob like this. It is hanging like this. Now, suddenly, in the switched on an electric field. Field is throughout space, no? So obviously, this bob will experience a force and move like this. Now let us see what are the forces on this. One is the electric force, the other is the tension. This is mg. This is theta. Now see again mechanics has come first here. They're all interlinked, I told no. This is theta. So what will be this? T cos theta. What will be this? T sin theta. Do you agree with this? Now you have T sin theta, T cos theta equals mg for equilibrium. No? Now if you divide one by the other, you have QE by mg. Anyhow, that is tan theta equals what? Theta is how much? Understood this?
Yes,
Hello.
sir.
Wait a minute, not active today.
Sir, it takes time to click on this speaker, sir. That is a problem.
Any doubt in this?
No, sir, no, no.
Okay, posted another question. Got?
Sir,
Yes, sir.
Done, sir.
In the question, is it angle theta or angle zero?
Huh? What?
In the question, is it angle theta? Sir?
Which question? That is theta, angle theta. The new question I have sent, the angle is theta. See here, as before a particle is thrown like this is theta. The only difference is earlier you used to have only gravity. Now apart from that, there is a charged particle, Q. So there is an electric field in this direction, downward direction. No? Therefore, there is an additional force on this. So therefore, force on the projectile. The projectile, no?
So,
Okay, so acceleration. This net force do you agree with this?
Yes, sir.
Now
Yes.
what is asking? Horizontal range. Remember what is horizontal range? Now you know
Square
that.
sine to theta.
Hmm? So range is nothing but u square sine
Sine
2
to
theta
by
by
g.
g. Yeah?
So g.
Now here you should take understood this.
Yes, sir.
I told you last year on entire first year is connected with second year, and these 2 years is again connected with your higher classes. You cannot leave. For example, you have studied matrices that is not required in integration. So like that, but this is all interconnected. We can't do anything. Got another question?
Yes, sir.
Hello?
Got.
Yes, sir.
I start the discussion of this problem.
Sir, 1 minute, sir. 1 minute.
Answer.
1 minute, sir.
Shall we turn this? Right, let us start this discussion. See, as I seen, there are two plates. Each plate has a length L. And as per the question, this is d by 2. He has projected like this. It should not come out the plates means it should maximum reach here on.
Yes, sir.
So we can say that horizontal displacement do you agree with it? So we can say that then you have Sx is equal to uxt. This is taken x, this is ut. So t equals x by u. Now Sy equals uyt plus half ayt square. I think he has given this now force is QE by m. This is d by 2, this is 0. T square means x by u whole square. Do you agree with this? So x square is mu square d by QE. Do you agree with this or not? So here we will find u square. QE by x square by md. Any doubt?
No doubts.
No, sir.
Now particle will not come out if x is less than L now. Do you agree with this?
Yes, sir.
If x is greater than L, it will come out now.
Yes, sir.
He is asking u max. Is it clear? So just like
Yes,
your
sir.
how you have the mechanics questions, here also you have the whole story. Only the additional force is the electric force. That's it. That means your first year can be repeated once again with this additional force. So slowly next force, magnetic force will also add up. So all these things will complicate the subject if you are not doing day to day. There is no independency in this. Each one is interconnected.
And
Completed?
Yes, sir. Yes.
See, I sent another question. See, shall it start? Here, flow. This is a
Yes, sir.
wall
Yes, sir.
with a charge. So, since he says there is an electric force, electric field in this direction, definitely there will be a force on this. Okay, so you can see that this is acceleration QE by M. So this is L. Okay, so we can see that this goes like this. What is the time taken? L is equal to UT plus half A. So here U is 0. Suppose the block hits it with a velocity V. Now we have V square minus U square equals 2AL. Okay, so A is 2 QE by M into L. So V is how much? Then in elastic collision, what will happen?
Sir,
So
kinetic energy is conserved. Kinetic
Conserved, sir.
energy.
body has same K,
So,
that means there is no loss of energy. It comes like this. Okay. Now suppose this will be coming to rest at some point. We don't know where it comes to rest. The velocity is 0. You can use V square minus U square. See, this is the electric field, therefore acceleration is this side only throughout. So V square U square 2 into this is retardation in this case.
yes, sir.
So you can see that V square is how much? That means the body exactly comes to the original position.
Yes, sir.
Do you agree? Therefore, again you can see that it goes. Okay, that means what is the time period of motion? This is t. We can say that. No. Do you agree with this? Hello?
Yes, sir.
Yes,
It can oscillate now to and fro. Is it simple harmonic? Hello?
sir.
Is the oscillation simple harmonic?
No, sir. No, sir.
Why?
Sir, acceleration is not related to this.
Acceleration is constant. It is not related to displacement. Agreed.
Yes, sir.
Understood this? Is it clear?
Yes, sir.
Shall I turn this?
1 minute, sir. 1 minute. Done, sir.
Right. So we have seen that how mechanics is involved in this. So these are all interconnected. So please be regular and do the work. Yesterday HCRM questions you have done.
Yes, sir.
Getting?
Yes, sir. Getting.
Don't postpone your work. Only one SR has come, others are not responding. Nobody else have done. Abra?
Yes, completed, sir. Completed.
So this is plus Q. I want to know the field here at a distance of R. What we should do here, place one Q naught, this is the force, agreed? So electric field is nothing but this force by Q naught. Do you agree with this? Followed.
Yes, sir. Followed, sir.
Now instead of this, we can directly so this is plus Q at a distance of R. I am keeping plus 1 coulomb. So what is the force on this? You can see
1/4 pi r square. Pi r square.
this is same, no?
Yes, sir.
Agreed or not?
Yes, sir.
Agreed.
Yes, sir.
That means wherever you need electric field, you can place charge Q naught and find the force. Then you can find F by Q to get electric field. Or the other way is place directly plus 1 charge at that point and find the force on that plus 1 charge. That itself gives what? Electric field intensity. Is it clear?
Yes, sir.
Shall I turn this?
Uh, yes, sir.
1 minute, sir. 1 minute. Done, sir.
So you can summarize that. by two ways. The second way is any of these methods you can do. Understood this? So this will be
Yes,
easier
sir.
instead of dividing and all, I'll do this.
Yes, sir. Understood.
Now suppose we have some body here. So this is charge is there throughout the body. I want to know the electric field at this point D. What I'll do, I'll take one dq. Okay, I'll place plus one charge here. The electric field is nothing but force on this one, electric field due to this. The electric field after that, what we should know? So the total electric field this is how we find now. Understood or not? Hello.
Yes,
Understood, sir.
yes, sir.
Understood.
Shall I turn this?
Yes,
Right,
sir.
sir. Done, sir.
For example, we are having a charge distribution. A line charge distribution is there. That means this is so here I want to know at a distance of r the field. What I should do? I'll keep one plus one charge here. After that, I'll choose one small element dq at a distance of x. How to get dq for charge q? For charge q, what is dq? Can you tell? This is dx. q by L dx. Do you agree with this or not?
Yes, sir.
Actually, dq is what? Lambda dx. Remember this? Lambda is q by L, no?
Yes, sir.
Hello.
Yes, sir.
So here, if you keep that, what is the electric field means force on this? 1 by 4 pi epsilon naught dq by x square. So you need to know the total electric field. Now at this point x is r, no? And at this point what you have, x is equal to L plus r,
R
no?
L plus R.
X is here, this is r. When you extend this x till here, you'll get this. This is 1 by 4 pi epsilon naught q by L. This is minus 1 by x integral of s. You are thorough with integration. Remember all this. Any doubts you have?
No, sir.
Understood how to find electric field? See, the first concept Coulomb's law is connected with electric field. Same, na? Because you know this, you are able to do this. Again, this is interconnected with next potential. So the syllabus goes on up to AC. All is interlinked. Then the next part is waves, light, optics, modern physics. That is a separate one. Understood?
Understood, sir.
Yes, yes, sir.
Understood, sir.
Right then. Go ahead. We'll meet in the evening. Okay? Any doubts are there till here? Boys,
No, no doubt, sir. Clear, sir.
be active, man.